Hey guys, so we're going to be calculating things like how high can you shoot a projectile, or what is its hang time if it goes to a certain height. We're going to do an example problem uh, on those types of problems for objects that are tossed or fired up in the air. Um, the first thing I'd like to point out is the equations. Instead of using the kinematic equations, we're actually going to just break it down a little simpler. So there's two equations to use. All right, the first one is d equals a half at squared. Only the t is squared. All right, and the a, you can write that down, is always equal to negative 9.8 meters per second squared from gravity. All right, your second equation is v equals at. All right, pretty simple two equations. D equals a half at squared and v equals at. The one rule about the equations, and you can see the t says t down in either of them. All right, you're not allowed to plug in the hang time to the equations. In fact, I wrote it here and I want you to write it down for these equations. Cut hang time in half before plugging into equation. All right, so if you're given a hang time in a problem, you got to cut it in half before you plug it in. And I wrote here, I want you to write this down too, always use t down in equations. All right, so the equations have the time down, which is half of the hang time in it, but they don't have the hang time in it. In fact, if you use the equations to calculate time, then the time you will be calculating is time down. These equations can't be used to calculate hang time directly. But if you calculate time down, you could just double it and get the hang time. All right? Okay, so equations, the number they spit out is time down, not hang time. Make sure of that. And let's do our example problem then. So I'll shift this up here a little bit. There's the problem. Okay, so read the problem with me. It says a baseball is hit straight up into the air and has a hang time of 6 seconds. Calculate the height the ball rises to. So we only have those two equations, d equals a half at squared and v equals at. You just got to choose one of them. We know that the hang time is 6 seconds. And if you're ever afforded hang time, I think what you should do is you should just cut it in half right away. So the time down really is just 3 seconds. All right? Because you can't plug hang time in the formulas, but you could plug time down in. So the time down is 3 seconds, and we have to calculate the height the ball rises to. All right? In letter A. So let's do letter A, the height the ball rises to. So out of these two equations, which one would get us the height? Well, v is velocity, so that's not going to get us height. So we really have to use the first one. D, or distance, is a kind of height. All right? So we'll use d equals a half at squared. Remember, the t you have to plug in is t down. A is always negative 9.8. T down is 3 seconds. Don't plug the 6 in there. That's the hang time. Not allowed to do that. A half of negative 9.8 is negative 4.9. Alright. 3 squared is 9. So the distance is going to compute as a negative, but you could just switch it to a positive after you get it. Doesn't matter. So the height the ball rises to is 44.1 meters. Right? So if they ask for height or talk about height, you know that's distance in your formula. Alright, now let's do letter B. Letter B asks, how fast was the ball hit with when it left the bat? Okay, so how fast? Well, how fast isn't D. How fast is going to be velocity, alright? So, go ahead and calculate V, velocity, alright? Oops, sorry. Sometimes I call the acceleration G because it's gravity, but our equation says A there. So, V equals negative 9.8 times T. Well, what kind of T am I supposed to use in any of these equations? I can't use the hang time. That's not allowed. I got to use T down. So multiply it by 3, not by the 6. This equation's pretty simple. You don't have to do any squareds or halves or anything. So you got 9.8 times 3. (29.4). What's the unit for velocity? It left the bat with a speed of 29.4 meters per second. Alright? Alright guys, so you're going to get a bunch of problems like this soon, just to practice, but you got to make sure just to use time down in those equations whenever you're calculating anything. And if a problem wants you to calculate hang time, you can't do it directly using the equation. You got to get time down first and then double it.